Okay, for our section 1.3, which is average rates of change, um, I'm going to be trying to do this. I'm probably going to have a calculator in one hand and my writing utensil here for my smartboard in the other hand. So if there's a little bit of pause in between what you see written, it's probably because I'm punching some stuff in. So I would suggest that you have your calculators available to you for this specific section for some of the things that we're going to be doing. Um, let's start off with the definition. Average rate of change of y with respect to x as x goes from x1 to x2 is the ratio of the change in input to the change in output. Change in output to the change in input. This is really a fancy way of saying y2 minus y1 over x2 minus x1, which hopefully you guys recognize as being the equation for slope. And really, when you're talking about the average rate of change of something, you literally are talking about a slope. You're talking about how something changes typically over time. So as one variable changes, how does the other one? And it's always going to be your output over your input, your y over your x. Sometimes they're going to be using different variables, but it's really the output over the input that you have to understand. And the denominators cannot equal each other. The x2 and x1 can't be the same because then you have 0 in the denominator, and that's not allowed. All right, so let's talk about a couple of concepts here. A secant line is a line which passes through 2 points of a curve. Whereas, and this definition is not on here, but a tangent line only hits 1 point on the curve. That's going to become very, very important. So the secant line passes through 2 points on the curve, and a tangent line only passes through 1. The slope of the secant line represents the average rate of change from x1 to x2. So let me kind of show you what I mean by that. If I was just to draw a sketch of some kind of a curve, okay, I'm going to make this curve just a standard looking like quadratic function curve, a parabola looking something like that. And I wanted to find the average rate of change maybe from this point right here and this point right here. There's going to be some kind of an average rate of change. Well, this point on the bottom, we'll call this one x1, y1. We'll call the point up here in the upper part x2, y2. If I drew a line in between these 2 points, I'm going to kind of dash my line even though it doesn't have to be. If I drew a line in between those 2 points, assuming I could draw it straighter than I did, apologize for that. Well, that line has a slope, and how do you find the slope of that line? Well, you take any 2 points on the line, and we have 2 points, and we do y2 minus y1 over x2 minus x1. So the slope, or the average slope, the average rate of change between these 2 points is y2 minus y1 over x2 minus x1. That's what it's asking us. That's what that definition up in the yellow box says. So when you're asked to find the average rate of change, you are literally just doing a slope between 2 points. That's going to give you the average rate of change. Okay. Gets a little bit more confusing now with the next one. The average rate of change of a function f of x with respect to x is also called the difference quotient. That's actually what that formula is right below. It's given by this function, which is f of x plus h minus f of x all over h. And again, h cannot be 0 because you can't divide by 0. The concept behind this is that x is changing by some value. So again, I'm going to do a little sketch here. And this time it's not going to be just a standard parabola, although it doesn't make any difference. So whatever that is, if I want to find the average rate of change from here to here, there is an x value associated with this. There's also an x value associated with this one out here. But there's a distance between these two values. That distance here is what we're calling h. So h really represents the distance between the two. So if the length of distance from this first point to the second point is h units long, then my second point, my second x value, is going to be the original x value plus that distance h. So there's where that x plus h comes in. It's just going to mean that there's some kind of a space in between the two x values, and we're calling the difference between those spaces h. That's where the h comes from in this difference quotient. So really, when you think about it, this f of x plus h is really, here I'm going to write this down here, f of x plus h, is really the same thing as, oops, not y squared, y2. As a matter of fact, let me write it in a different color. This is like saying y2. And then I'm going to subtract f of x. Well, f of something, again, is a y value. This is like y1. It's the first y value that we started off. So this is really like y2 minus y1. And then, like I said, this h value represents the difference between the two x's. So it's really like x2 minus x1. We just call it h instead of writing out the x2 minus x1. So it really is the same idea as what we were doing. It's just a slightly different form. Okay, so let's see if we can carry this through to the next page. We want to find the simplified form of the difference quotient and complete the table. The simplified form of the difference quotient is a little bit more challenging algebraically. Okay, we're going to do the simplified form here for the ones that say 6 and 12. There's another one on the back of these worksheets. I think it's like 50 and 52. We're not going to write out the entire simplified form. We're just going to write out the difference quotient and see what it would look like. All right, these we are going to do. It's a little bit of work. So f of x, so if you look at the equation, here's your equation. F of x, well, that's given to you. So that's going to be easy to fill into this equation. It's the f of x plus h part that always hangs people up. So I want to give you something here, and I'm going to put this above the problem because it doesn't actually relate to the problem specifically. But if I wanted to do f of 3, okay, I think most of us know that f of 3 means that I'm going to take 3, because 3 is in the same place the x was, and I'm going to plug it in for the x's in my function. I hope that makes sense. 3 is literally taking the place of where the x was. See how the notations are the same. 3 is taking the place of the x, so 3 is taking the place of the x here and of the x there. Now I'm going to erase those lines in just a second just so I can have the function back. But that's what f of 3 would mean. Then you would just simply evaluate. You do 3 squared and then add 3 to it. Okay, that's the idea behind f of something. So if I want to do f of x plus h, the fact that there's still variables inside of there doesn't change the general idea. This literally means this x plus h took the place of that x right there, so x plus h is going to take the place of the x's in my function. So if I take out the x's, and I'm going to replace those with x plus h. Okay, that's exactly what that means. So then we would have to simplify this just a little bit. We are going to have to FOIL the first one because that is x plus h times x plus h. So this would be x plus h times x plus h. Now this is one of those things, unfortunately, that I have to assume that you guys know how to do already. So I'm going to write out what the FOILed x plus h times x plus h would be. I don't care how you do it, whether you do a FOIL, whether you do some kind of a box, or you have some other method. You would get x squared plus 2xh plus h squared. That comes from foiling or doing x plus h times x plus h. But then I also have to add the extra x plus h to it. That is the simplified form, believe it or not, of f of x plus h. So what I just did was this piece right there. So now in order to write my simplified difference quotient, I need to plug the first piece, this one, into the top. So that's x squared plus 2xh plus h squared plus x plus h. That's the f of x plus h that I circled in green. I have to subtract f of x. Well, f of x is given to us. F of x is this stuff right here. So I have to subtract that. I'm going to put it in parentheses because it is an entire quantity of something. And then I have to divide that whole thing by h. If we have done this correctly, and this is a good little hint, if we have done the simplification correctly, anything on the top, on the numerator, that does not have an h attached to it has to go away. It has to algebraically subtract out. And this is going to be the case in this case. Here I have x squared. That does not have an h in it. But here I have minus x squared. So x squared minus x squared is going to cancel out. It's going to make 0. It's going to go away. The 2xh has an h in it. The h squared has an h in it. But this x sitting right here does not. But here's the good thing. I've got a minus x. So x minus x is also going to cancel out. It's going to go away. So that's gone with this one. That's gone with this one. All we have left are things that have strictly h's in them. So when I rewrite this, because it's a mess looking right now, it's 2xh plus h squared plus h all divided by h. And the reason that we need this to happen is because ultimately we need the h on the bottom to go away. Well, we can make that happen because I have h's left in every term on the top, which means I can factor an h out. It's a common factor, so I can factor an h out of the top, which leaves me with 2x plus h plus 1 all over h. And the reason that that's good is because now these h's can cancel out. They will divide away. So the most simplified form of this is what's left over in that parentheses, which would be 2x plus h plus 1. That is the most simplified form of the difference quotient. Now, if I'm going to use the table here, I'm actually going to have values to plug in for h. So this is actually going to make things a little bit easier, but this is where I'm going to have to use the calculator as well. So here's x, here's h. If I want to do f of x plus h, that means I need to add x and h together. So x plus h here is 7. So the first one, x plus h is 7. If I add the x and the h together, I get 7. So I need to do f of 7. And then I have to subtract f of x, but x is 5, so I need to subtract f of 5. And then after I do that, I need to divide that whole thing by h. And h is 2. Sorry, I should have put a 2 in there. Divide that whole thing by 2. So this is where I'm going to end up using the calculator. F of 7, plugging a 7 in, is, let's see, 7 squared is 49. Excuse me, plus 7 more is 56. Minus plugging a 5 into the function is going to be f of 5, so that's 25 plus 5 more is 30, all over 2. 56 minus 30 is 26, divided by 2 is 13. All right, so I'm not going to write out every single piece here, but that's how you would do it. So the next one, h is 1, x is 5. That means f of x plus h is f of 6. And then you're going to have minus f of 5. That's not going to change. But the over what the h is going to change. The h is now 1. So I'm going to plug all this stuff into my calculator. Use the same exact premise here. So f of 6. As a matter of fact, I'll write out one more just so you can see it. This will be f of 6. That's a bracket right there. Minus f of 5. And then divided by h, but h was 1. So I really don't have to divide by anything. So I'm going to go ahead and plug this stuff into my calculator, and I'm going to fill out the rest of the table for you guys, and hopefully you can practice doing the same thing. All right, so the magic of being able to pause the video allowed me to plug all this stuff into the calculator, and those would be the values for the last two pieces. So one of the things that I want you to notice is the value went from 13 to 6 to 11.1 to 11.01, assuming that I did that correctly. Which, of course, I'm double thinking now, and I did not do that correctly, so I apologize. That second one should not be 6. I forgot I'm dividing by 1, because I ended up with 12, and for some reason I divided 12 by 2. It's 12 divided by 1, so really that should be a 12 there. That makes more sense. So it went from 13 to 12 to 11.01 to 11.01. There is a pattern developing there that we're going to get to, just not quite yet, but I want you guys to see that. All right, so let's go ahead and look at number 12. And again, if I'm moving too fast, you can always pause it. That's the nice thing about these videos. You can pause it and go back. If I'm moving too slow, you can fast forward a little bit. It's up to you. All right, so here we want to do f of x plus h minus f of x. Again, f of x is given to us. It's the f of x plus h that we have to work on. And remember, that's taking the x plus h and plugging x plus h in where every x was. So this will be 1 minus where that x was. I am now going to plug in x plus h. This one is a pain. It is x plus h cubed, which means it's x plus h times x plus h times x plus h. I happen to know a shortcut to this, but I don't expect you guys to know that same shortcut. I am going to write it out because I'm going to save some time here, but you would have to multiply or FOIL x plus h times x plus h, which we did in the one above, and then multiply it out by another x plus h, which is not a FOIL, but it's a long multiplication of polynomials. So again, I don't know what method you guys learned, but hopefully this is going to be the result that you end up with. It should be, and I got to keep this in parentheses because I'm subtracting it, x cubed plus 3x squared h plus 3xh squared plus x cubed. Okay, that is f of x plus h. I'm going to go ahead and simplify it by distributing the minus sign throughout the whole thing. So 1 minus x cubed minus 3x squared h minus 3xh squared minus h cubed. So that's the part up here on the numerator. That's this part. So I'm going to fill that in. So that would again be 1 minus x cubed minus 3x squared h minus 3xh squared minus h cubed. And then I have to subtract the original function f of x, which was 1 minus x cubed. Then I have to divide the whole thing by h. So again, remember what I said in the very beginning of this part? It says that anything that doesn't have h attached to it in the numerator has to algebraically subtract out. That has to happen. So we can make that happen because I have a 1 here that does not have an h attached to it, but I also have a minus 1 right here. So those are going to cancel out. The next term I have is a negative x squared, a negative x cubed. There's no h attached to that. But over here, and this is where you have to be careful, I have a minus x cubed. Remember, minus minus makes plus. So I have a minus x cubed in the first one and a plus x cubed in the second one. These are going to cancel out. Those are gone. Everything else that's left still has h's in it. So when I write out what's left, I have minus 3x squared h minus 3xh squared minus h cubed all over h. Now, remember, the goal is to get rid of the h in the denominator. We want that gone. So I can now factor an h out of the top, which is going to leave me with negative 3x squared minus 3xh minus h squared all over h. Now that allows me to cancel out these two h's, and all I have left in the most simplified version is what's left in that parentheses. So my final result here is negative 3x squared minus 3xh minus h squared. That is the most simplified form. And the chart is just like we did before. They gave us the h value, so we're literally going to plug in the x and h and see what we get, and then we're going to evaluate the functions that way. So the first line would be f of x plus h, that's f of 7, minus f of x, well that's f of 5, and I'm going to take that whole thing and divide it by my h value, which in this case is 2. So again, I'm going to go ahead and pause this. It'll seem like I'm right back real quickly, but I'm going to figure out these values and I will fill them in for you. All right, voila, there you have your chart filled in. So the values go from negative 109 to negative 91 to negative 76.51 to negative 75.1501. Again, there is a pattern developing there. Those numbers seem to be approaching a certain number, and that, again, is going to be the very important part that we eventually get to. It just won't be in this section in particular. So hopefully you're going to practice plugging those things into your calculator, because I'm going to tell you right now that's probably one of the hardest parts of the whole thing. Obviously, there's a lot of algebra involved in simplifying these things, but plugging the stuff into the calculator for some reason really gets people hung up. So practice that. Please make sure you get the same numbers that I do. And if we don't, bring that up in class next time. We'll see if we can figure out what happened. All right, we're going to move on to the one at the bottom here. So we want to estimate the average rate of change of the percent of new employees from 2003 to 2007, from 2007 to 2012, and from 2003 to 2012. So we basically have three different estimates that we're going to do. So in order to do that, we basically just need to find those points on the graph, and then we're going to do a slope formula between those points. That's really all we're doing. So for the first one, we want to estimate the number of new employees from 2003 to 2007. So if I go to 2003, which looks like it's right here, looks like there's 0 new employees. And in 2007, looks like it's right here. We'll go up to the graph. That looks like there are 2 new employees. So the rate of change there is, let's see, the y value, y2, would be 2. Y1 would be 0 over 2007 minus 2003. Those are the change in the x value. So I'm going to get 2 over 4, or 1/2. So that's the first one. The percent rate of change is 1/2. So it's changing by 0.5% per year, it looks like. The second one, let's see, I'll do this one in green. We want to go from 2007 to 2012. So 2007, again, is right there. 2012 is right there. So the y value at 2012 looks like it's 5. The y value at 2007 is 2, so there's the change in the y's. And then over 2012, because that went with the 5, minus 2007, which is going to be 3 over 5. And as a decimal, that would be 0.6. So that would be a 0.6 or 60% rate of change. I guess I should probably write these in percentages. Since that's 1/2 at the top, that's 0.5. As a percentage, that is the same thing as 50%. Remember, you move the decimal 2 places to the right or multiply it by 100. So in order to do the percent here in the second one, that is the same thing as 0.6 when you divide those, which is going to be a 60% increase. And then the last one, I'll use black instead of the red because the graph itself is in red. So we're going to go from 2003 right here to 2012 up there. So that's going to be at 2012 was 5, 2003 was 0, over 2012 minus 2003 is going to give us 5. 12 minus 3 is going to be 9. And then 5 divided by 9 is not a perfect decimal, but it's going to be close. I believe it's going to be 55%, but we'll see. Whoops, 5 divided by 9, yeah, is 0.55 repeating. So it's approximately 55%, but if you add another 5 on there, it's actually really going to be like it's rounded up, so it'll be about 56% rounding at the end. So that's all it is, average rate of change, the slope between 2 points, really all that is we're looking at. All right, and like I said, 50 and 52 we'll set up, but we're not going to do the whole thing of, but we will do 29 here, and then we'll be finished with that section. Okay, number 29, it says, based on the data from Major League Baseball, the average price of a ticket to a Major League game can be best approximated by P of X equals, and then that long function, excuse me, where X is the number of years after 2008 and P of X is in dollars. So X represents the number of years after 2008 and P of X represents the actual money that's brought in. Okay, so we want to find P of 4. Well, P of 4, of course, just means plug 4 into the entire thing. So I'm going to have to definitely use the calculator on this one. So 0.06 times 4 to the 3rd power minus 0.5 times 4 squared plus 1.64 times 4 plus 24.76. Okay, if I plug that in correctly, I get 27.16. That would be the profit there. P of 6, do the same thing, but plug the 6 in. So let's see what we get there. 0.06 times 6 to the 3rd power minus 0.5 times 6 squared plus 1.64 times 6 plus 24.76. And for that one, I get 29.56. Then in part C, it simply wants us to subtract those two numbers. So 29.56 minus 27.16 is 2.4. So P of 6 minus P of 4 is 2.4. And I guess since we're dealing with money, we'll write it as 2.40. So find P of 6 minus P of 4 divided by 6 plus 4. Well, we already did the P of 6 minus P of 4, so all we have to do now is take $2.40. That looks like a 2 times 40. Let me rewrite that. $2.40. Divide that by 6 minus 4, which is 2. So that's going to give us 1.20. So it says what does this change represent? Well, it is the rate of change from from 4 to 6. Remember that the x values that we are plugging in represent the number of years since 2008. So what this says to me is that this is the average rate of change, because remember that's what we're finding when we find these slopes. The average rate of change of the price of a ticket and let's see, 4 years after 2008 would be 2012, 6 years would be 2014. So from 2012 to 2014 would be $1.20. So in other words, the price of tickets averaged an increase of $1.20 from 2012 to 2014. That's what it says to me. Average rate of change. All right, the last two. Again, we're just going to set these up. We are not going to simplify them because that is a pain. To do the difference quotient, remember what you need is f of x plus h, which means you are going to substitute x plus h in for the x's. So where the x was here, I'm going to substitute x plus h. And the difference quotient was f of x plus h minus f of x all over h. That's from the other page. So f of x plus h is this one, minus f of x, that's the original function, over h. Simplifying that would be a real pain. Again, I know a shortcut to do the x plus h to the fifth, but that's way too long for us to write out. So just set it up like that, and that'll be good for now. Number 52, f of x plus h. Again, we are just substituting in x plus h where the x is, so it's 1 over. I'm going to take away the x, and in its place, I am going to put x plus h. So that is f of x plus h. So I'd have to do 1 over that minus the original f of x, and that whole thing over h. That one wouldn't be as hard to simplify, but it's still a lot of work, and it is not necessary for right now. So we are going to leave it at that for right now. There are going to be easier ways for us to be able to figure these things out in the future. That wraps up 1.3. That should be plenty. I will go ahead and post your homework for this one as well. Both of the homeworks will be due Tuesday by 5. I hope you guys have a great weekend, and I will see you on Tuesday evening.